is effective for the sample size determination. Four methods. That first one is a formula method. Second one, it is a table, that is a sample size determination table. Third one, nomograms. And fourth one, the computer softwares. In the computer softwares, we have seen the three methods. That one is a surveysystem.com. Second one is it is a EPI info method. And third one we are discussing today, it is a G Power Tools. But before discussing the G Power Tools, we will go through the yesterday's some sessions, yesterday's research design. So I share here the PPT and we are going to discuss the research design, how the research design affect our sample sizes. So I'm sharing my PPT here. So now we yesterday we are saying that the one formula that suppose there are two comparative different populations are there, to calculate the different population proportions, what the formula we are going to use. Yesterday we saw this formula on the Microsoft Word, but it is not possible to understand the formula in a Microsoft Word thing. That's why I put it here on a PPT. That is n is equal to z alpha plus z beta bracket square into bracket p into 1 minus p plus q into 1 minus p. Now here are we are considering the research design that the two comparative groups are there. If there are the two comparative groups, that means in every group the population is different. In the first group the population is different, in the second group population is the different. I mean the population is different means the responses are different. That means, so we are using this particular formula and it's equal to z alpha plus z beta. Now here the z alpha, it is a z variant, it is always have a constant value, it is a 1.96 for the 5% level of significance. And the z beta, which is actually the power of test, but we taken it is a constant at maybe 0.80 or 0.84. So P and Q are the proportions of the variable of the two different groups, and we are which are taken from the parent article. So this is the formula we are comparing, we are using for the two different proportions. Now here is the that example that we approximate estimates we are taken at the 80% power. Type 1 error, that is a level of significance, it is a 5%. Again, type 2 error, it is a 20%. Why it is so? Because power of test, it is a 80%. Therefore, type 2 error beta, it is a 20%. So, proportion of the events or the outcome in either of the groups is 95% or the 70%. Now, I substitute these value, that is the proportion of first group, it is a 95%. Proportion of second group, it is a 70%. Therefore, the calculated sample size, it is n is equal to 32.300. This is a normal integer figure, n is equal to 32. But what happens sometimes for the follow-up studies, to avoid the loss by loss to follow-up or the attrition rate, kindly consider the recruiting 5 to 25% more subjects, so that even after the attrition we would be able to achieve the minimum sample size. So taking into consideration the attrition of 10% n is equal to n by divided by 1 minus 0.1, we will take it, this is a 0.35.55. That means our approximately sample size which are taken for the experiment, that should be 36. And this is called as a valid sample size for the calculations. So here now we are going to discuss that how different study designs affect our sample size. We'll take here a simple example. It is a cross-sectional survey. A cross-sectional survey collects the data at a specific point of the time. So for example, suppose we want to study the consumer preferences towards the different brands. So for this, what the formula we have to use? It is a very simple formula. It is n is equal to z square pq upon a square. That is what exactly with a pilot study, I will find the consumer preferences as a P, as a proportion for the different brands. Therefore, here the proportion is taken as a P and we will calculate the sample size over here. This is the one example. Now we'll go for the another example. See here, here is the one longitudinal study. This study follows the subject over extended period of time. How much extended period? That means up to the 5 years or 5 to 10 years. It is a long study. Long study. Therefore, we are collecting the data at the multiple time points. Maybe after 6 months, maybe 8 months, or maybe 1 year, or 2 year, or 3 year, or many of the years. Therefore, we are collecting the data at the multiple time points. Let's say you want to examine the employee job satisfaction over the years. So, in this case, what happened? We cannot directly calculate the sample size over here. This sample size calculation depends upon a specific statistical analysis techniques that what you are planned to use. That what exactly the statistical techniques you are going to plan. Either it is before after, or it is a systematic sampling that varies at every time interval you are going to collect the sample in this way, or it is a stratification that you are preparing the particular data or groups of data. From the groups of data you are collecting the samples. Again, it may happen that this collection of the points, it may be the different areas. Then at the cluster sampling you choose first the cluster, that the area, and then you are doing the random samples technique over here. Therefore, at such a study, there may be the repeated measures of ANOVA, or maybe the correlation and association of the variables, or maybe you are going to find the data is univariate or bivariate or multivariate. Along with this all, you are going to ask the what exactly my sample size over the study. Therefore, we whatever the study design is there, as per the study design, we are going to consider this. Take a simple example over here. It is a case study. What is a case study? A case study investigates a particular individual or organizational or a situation in depth. Okay, there is a single study. Therefore, wherever the individualized study is there, the statistics cannot be applied. Okay, that's why the sample size determination is not applicable in the case studies, because the case study it is for the single one, single individual, single organization, or the single situation in depth. That's why in this case, sample size is not applied at all. Take an example of case study explores the management practices that have contributed to the Wipro's success and the transformation into the leading player in the industry. Therefore, in this case, this is the only one case study. For one case study or one patient or one respondent or one situation, we cannot discuss the sample size over here. Therefore, this is one of the research design that we are discussing. Next one. Here we are discussing the experimental studies. Experimental studies involves the many variables or the manipulation of the variables. Those may be dependent variables, independent variables, and we are going to observe the effect of that particular variables on a dependent variable. Take a simple example of the SOR method. What do you mean by SOR method? It is a stimulus, response, and outcome method. Every experimental study goes on in this way. There is a stimulus. With the stimulus, there is a response, and with the response, there is an outcome. Therefore, wherever the stimulus is there, there is a response. And wherever response is there, with the response, we are observing the particularly outcome. Therefore, this stimulus response theory shows us that what exactly the experimental study is there. Okay. So we are conducting the experiment to analyze the impact of training program of the employee performance. So what we do, first of all, I have taken a pre-test of the employees. I have prepared the questionnaire. I have taken the pre-test. After the pre-test, I have given a training program. After the training program, again I am considering the same questions as a post-test. Therefore, I can understand what exactly the employee performance over there. Now, my questionnaire of the pre-test, it is a stimuli. For the stimuli, I will get a response. And what is a response? I will get an outcome from my response. That is why it is an experimental study. So we can use the normally power analysis to determine the sample size required to detect the significant difference between the groups. It again go for the different types of experimental study. It may be pre-experimental study or maybe quasi-experimental study. That is maybe on the time periods we are collecting the data from the different experiments, which is called as a quasi-experimental study, where maybe the random variables are not there, but still the responses are counted. Maybe the true experimental study is there in which SOR theory is used. So at the different experimental studies, we are calculating the different types of sample sizes. Now, this is one of the example. It is a cross-sectional survey. So I have taken here an example as a conducting a survey to understand the consumer preferences for the new products. Yesterday we are discussing this particular research question. So here is the simple formula, that is n is equal to z square p into 1 minus p upon e square. Simple formula is there. Pilot study of consumer preferences has to be conducted first. Take a proportion of that, take a prevalence of that, and then use the formula for the cross-sectional survey. Now, here I am going to explain you, this is the taxonomy of the designs covered. This is a particular taxonomy. This is, suppose, whenever I am collecting the data or whenever I am plan of the study or whenever I plan the research design, I plan for my variables. That means our parameters. Whatever the parameters to the population, those are called as the parameters. And whatever the variables considering the sample, those are called as a statistic. Therefore, all the variables should considered. Now, here, suppose my parameters are, or the variables are numerical. Two numerical variables are there. Then either I use the parametric test or I am using the non-parametric test. It depends upon the normality of the test. Again, suppose my variables are numerical and my normality proves, then I will use the one mean t-test. Or it may happen that normality is not proved, then I will use the one mean Wilcoxon test. Again, suppose here is the example that one numerical variable is there and one categorical variable is there. Okay, categorical variable groups are two. Now the independent variables are non-paired. Then I am going to use this comparative two-mean test or the if normality is proved. Again, normality is not proved, then I will use the man-Whitney t-test. Suppose my parameters are dependent parameters, then I'm going to use a paired t-test for this or paired Wilcoxon test for this. This is all the taxonomy of the designs covered. Whenever I plan the research design, I know what is my objective, what is my hypothesis. Whenever I set my hypothesis, we set the hypothesis, the dependent and independent variables are very cleared. Okay, with the clear dependent and independent variables, we use this particular designs of taxonomy to understand that which test is applicable to our data. And according to the test, we are going for the sample size calculation, that I will get a exact, accurate, reliable, valid results with all the
Excellent.
basis of the sample size calculation.
Excellent.
So here is one of the taxonomy the designs covered. Take an example of categorical variable. Categorical variable. All the responses are qualitative. All the responses are qualitative. There are no numerical values. Then I will use the proportion test. Suppose there is a one categorical and one categorical, two independent categorical variables are there, then I'm going to use the Fisher exact test. Or maybe dependent variables are there, then I will use the McNamara test. Okay, in this way we are covering the designs, research designs, and according to research designs we are going to calculate the sample size. Okay, I will give you the one example of this that you will understand. Take an example of the hypothesis. Hypothesis 1, meditation significantly improves happiness. Simple example is here. I said the hypothesis, meditation significantly improves happiness. Now my dependent variable, what is my dependent variable over here? It is a happiness. Happiness, the degree of happiness. Degree of happiness depends upon the meditation. Okay, so independent variables are the meditation, levels of meditation. It may happen that levels of meditation are there, and levels of meditation depends upon, significantly depends, improves the happiness. In this way, again, happiness, degree of happiness, it may be the qualitative value but this qualitative value, we are transferring into the quantitative scale. Again, the level of meditation, again it is a qualitative value, but again we are transferring the data into the quality levels, quantity levels. Okay, in this way we'll go with this. Again, we are discussing hypothesis 2. Purchase decision of the mobile is associated with the brand value. Now dependent variable, what is dependent variable over here? It is a purchase decision. Okay, how I am going to purchase a mobile? Maybe independent variables are only 4 variables we considered. One is a brand rating. Is it a 1 star, 2 star, 3 star, 4 star? Maybe the price of the mobile, or how much storage it has, and what is my prestige issue that this mobile I should have this mobile. Therefore, in this way, you can find the price is a numerical value, numerical variable. Now the storage, it is again the numerical variable, but the brand rating, it is a categorical variable, and prestige is again the categorical variable. So here are two numerical variables and two categorical variables, and the dependent variable is again the categorical variable. So what I am going to do here, we are using the particularly crucial values test. In this way, now I decided that this is my test I'm going to use, and according to test in the G power tools, we are calculating the sample size. Okay. Now, here is the hypothesis number 3, that growth of the plant is not associated with the soil fertility. Now you tell me what is dependent variable and what is independent variable. Anybody? Anybody of you can explain what is the growth of plant and not associated with the soil fertility?
Growth of a plant is an independent variable, and soil fertility is a dependent variable.
Ma'am, exactly opposite you are saying.
Yeah, exactly. Soil
Exactly opposite.
independent variable,
Uh,
and growth of plant seems to be again independent because not as used. So I think in this case, growth
what
of
is
plant.
changing? No, no, no. I'm asking you what will change? Growth of the plant will change or soil fertility will change? If soil fertility will change, then
Okay.
growth of plant. So
Yes.
suppose
So
the soil is not
independent.
good, then plant will not grow.
Hmm.
Okay.
Yes. Ma'am, one more thing I
Suppose
need to
for the
ask.
soil fertility, I'm using the fertilizers NPK. Okay.
Okay.
Okay, I'm using the fertilizers NPK. Now NPK is my independent variables, and growth
Okay.
of the plant is dependent variable. For the soil fertility, I'm using the water intake properly. Then water intake, it is an independent variable, and growth of the plant, it is again the dependent variable.
Okay.
Okay, so therefore we need to understand, whenever we set a hypothesis, we need to understand what exactly I'm going to find. What exactly the research, what is going to associate, which variable associate to which variable. Okay, so take a last hypothesis. Betadine significantly helps to heal the wound. Now you tell me that what is a dependent and what is independent variable.
Wound healing is dependent and betadine is independent.
Yes.
Betadine is independent. Okay, what will
Yes.
change, ma'am? What will change?
Wood.
Healing of wound.
Healing of wound. Then efficacy of betadine. Is it?
Hmm.
Efficacy of betadine is significantly effective on the wound healing or not? This is our
Hmm.
hypothesis. Is it there?
Hmm.
Yes.
Yes.
So efficacy of betadine, it is a dependent variable. So,
Hmm.
because wound has different independent variables. Which are those? Suppose wound is there, then size of wound is there, color of wound is there. There may be discharge in the wound. Is it there? Swelling may be there. The tenderness may be there. These are the independent variables. That whenever the wound is healed, these all independent variables should be healed. Yes or no?
Yes.
Yes, therefore, efficacy of the betadine, it is my dependent variable, and all are the independent variables. That is, the parameters of the wound or the statistics of the wound or the variables in the wound are the independent variables, and the efficacy of betadine, it is a dependent variable. Are you getting me? There may possible that with the dependent and independent variables, there are some confounding variables. or maybe lurking variables. They are not directly relate to the dependent variables, but indirectly they are showing their efficacy. But we are not discussing much more on this hypothesis thing. I need to understand you that how the testing of hypothesis or the research design is effective on a sample size determination. Okay, so we'll go next. Now here is one table I am giving you. This is particular one table that whenever we set the hypothesis or whenever we set plan our research design, we will find that what exactly my parameters of the study or what exactly the variables in the study. According to the variables of the study, we are going to understand that which type of test is applicable over here. Take example, numerical value is 1. Again, categorical values are all 0. Therefore, I am using the one sample t-test. Again, numerical value is 1. Again, but the data is not normal. Data is not normal. Then I am using the Wilcoxon t-test. Suppose my numerical value is there, categorical value there, or maybe one or two or more categorical variables are there, but data normal. Then I'm going to use the pair t-test over here. Data is not normal, then I'm going to use the Wilcoxon pair t-test. Okay. In this way, we are going to use this particular table, that what exactly type of the test we are using in our testing of hypothesis, or maybe at the end of the statistical analysis, my whatever the sample size I decided, it will give me the valid, reliable, precise results. That is why whenever I use my Prisma model in the review of literature, that should reflect exactly the generalization of the population. Therefore, this will help you that to use the Prisma model also in the review of literature. So this is the table that we are discussing here, that in this way of the quantitative variables and qualitative variables, that is a categorical variables, nominal, ordinal variables, whatever we are using, we take a help of this particular table and we decide the what exactly the test or what exactly the statistical analysis we are going to plan for our study. That's why it is easy for us to calculate the sample size. Are you understanding this all? Yes or no? Hello?
Yes, ma'am.
Okay, thank you. So now here is one table, the chart I have given here. The sample size depends upon, first of all, the hypothesis, that what hypothesis we set. It is a conclusion of our study. It will take a help of sample design. What is a sampling distribution? Sampling distribution or sample design, as well as our what is our sampling method. And after that, the statistical analysis, whenever we do our statistical analysis and interpretation, it will give us the proper accurate results with a sample size. So we need to understand what is my optimum sample size for my research. Now, what exactly the sample size? Okay, whatever we are selecting the population over here, from the population we are taking the samples. Okay, on the base of the sample, again we are doing the inferential statistics. Okay, inferential statistics on the base of sample. And what have happened, this sample will predict us for the population, but whatever our prediction is there, that should be implemented properly. That should be proves our theory. That's our proves our inductive theory. That inductive theory is proved by the sample size determination. Now, here is some qualitative research example, that in a qualitative research, what happens every time, that everybody has a different perspective. Everybody has a different, any researcher or maybe the students or the scholars, PhD scholars, they want to see the data in a different aspects, like a theory of RBT, rational behavior therapy. It is, suppose one person says that I want to see the world through my eyes of the respondents. Whatever the respondents say, I will do it. It will prove my brand value. So it as the eyes of my respondent. I want to describe a contest in a lot in a detail. He want to write it all in a very deep level, in a contest level. Third one says that I want to show how the social change occurs and I'm interested how the things come to be. This is another view of it. I really want my research approach to be flexible and able to change. Therefore, whenever qualitative research is there, there is some little difficulty for the sample size determination. That is why what we do, we'll go for the statistical parameters, statistical analysis, planning, and come back to the sample size determination. So now we are discussing about the sampling methods. Now these sampling methods are of the two types, either systematic, stratified, cluster, simple random. This we call it as a probability sampling methods, that we are certain about our random data, or we are certain about our sampling methods. Again, some sampling methods are there which are non-probability sampling methods. Okay, these are the methods. One of the convenience sampling method is over here. So we'll see that how it affects. Now, here is one example of the random sampling. Random sampling. Random sampling means data, every respondent has an equal chance of give the response in our study. It is a random sample. So here is one example that estimate the average level of satisfaction among the university students. Now we are going to calculate the population mean. It is here the continuous variable. So samples may be calculated using the formula n is equal to z square sigma square upon e square. Now you can see over here. Here is the formula n is equal to z square sigma square. Where this sigma comes? Sigma means it is a standard deviation. Where from the standard deviation will come? Because the university students, the previous university students gives us a standard deviation value of the 2.5. Okay, how I get it? By the previous records. Previous records, I got it, the standard satisfaction level, it is a 2.5. Therefore, I decide my margin of error as a 0.5. Sample size calculation may be the 96 students. So rounding up this particular value, the sample size should be 97 university students. So in this way, the method of the sampling, it is a random sampling method. Therefore, as per the method of sampling, as per the design, we'll go for the determination of sample size. Here is one more example, which is a stratified sampling. Sometimes what happen, only the randomization is not applicable to the data. We have to go for the 360 degree of sampling methods. That suppose take in one example, that understanding political attitudes among the different age groups in the population. Then different age groups are there, different age groups has a response, different response is there. Then here, however we divide the age groups in the different strata or simply different groups, according to the group we are going to calculate the sample size in the different groups, so which is called as the stratum in the population. So this stratum will help you to calculate the exact sample from that stratum or from that group very proportionately. Here is that example, that investigating voter preferences in the study. Suppose a city has a total 10,000 eligible voters. Take this example. So what we do, the stratification we done as a divide the population into strata based on the age group 18 to 25, 26 to 40, 41 to 60 and 60 plus years. So what we do now, here are the four groups. Four groups are there. Now my total population size, it is a 10,000. Okay. So sample size of each stratum will be determined proportionately based on the size of the proportion. Because the particularly 18 to 25, 500 people are there. Again, this 500, this 500, this 500. Again, the population groups are ages of the 20%, 30%, 35%, and the 15% respectively. So, suppose my desired total sample size is a 500 voters, then I divide this 500 voters into this proportion of 20%, 30%, 35%, and 15%. This is called as a particularly stratification. According to the groups or according to the strata, we will take a data accordingly, which is a stratification. But this sample size should be proportionate to our strata, but exactly opposite to the cluster sampling. Because at the cluster sampling, what we do, first of all, we decide the cluster. Cluster means area. Then whatever the clusters we have decided, suppose a particular cluster has a more respondents according to our specifications, then take a more sample from that particular cluster. Or suppose a particular cluster has a less samples, less respondent in that cluster, then take a less sample size from this is possible in a cluster sampling, but it is not possible in a stratification. But normally whenever the stratification is there, we take a sample size according to the size of the strata or size of the group over there.
Excuse me, ma'am.
Yes.
Ma'am, in my study, here the employees are there and leaders are there. So
Yes.
we need to apply the stratified sampling or what, ma'am?
Yes, exactly. The leaders are there and employees are there.
Yeah.
Then you have to calculate the leaders population, employee population, or maybe in your area or maybe in your particular time period. And according to the strata, you need to calculate the sample size separately or for that.
Okay, it will be stratified sampling only applicable for that study, no, ma'am?
Yes.
Yeah,
Only
thank you.
stratification will possible over here.
Yeah, thank you very much, ma'am.
Okay.
Ma'am, another question.
Yeah.
Impact of AI and robotics in hospital, whether it is sampling technique is stratified or not.
Again, tell me.
Impact of AI and robotics in hospitals.
Impact of AI in robotics in hospitals.
Yes, ma'am.
Suppose now this depends upon which area you are taking. It is in a particular city or in a particular
Bangalore city.
hospital
Bangalore, ma'am.
in Bangalore.
Yes,
Then again, what is your exactly the population size? Are you going only for the hospitals? Then it should be
Allopathic
the
hospital. I have
stratification.
mentioned
It may be
allopathic.
random sampling.
Okay.
You use the random sampling over there. Because not many hospitals are using this robotics method. Very few hospitals are there.
Okay,
In
ma'am.
that case, you take a random sample over there.
Okay, ma'am. Thank you, ma'am.
Here is the one more example of the stratification, assessing the customer satisfaction in a retail store chain. The retail store chain has a 50 stores according to the different cities. Now see here, these 50 stores are different cities. Okay. So we divide the population into the strata or a group based on store's location. What exactly the location of store? Now the urban stores or suburban stores or the rural stores. Now this is our strata. That urban store, suburban store and rural stores. Now here the sample size calculation. In this example, sample size of each stratum can be determined based on the practical consideration and the desired level of representation. For instance, sample of 10% of the stores from the each stratum. Then sample size, maybe urban stores, how many urban stores are there? 50. Then 10% of 50, 5 stores. Again, suburban stores, maybe 10% of 50. Or rural stores, 10% of 50, 5 stores. Therefore, here, how many urban stores are there in a particular city, particular area? It depends upon what exactly the stratification we will cover. Or it may possible the cluster sampling or also here. Suppose in a cluster, the more retail stores are available in the urban stores. Then take a more percentage of 20% of the 50 stores over there in an urban area. In this way, you can divide the clusters also in a stratification. Now, here is the one example of the cluster sampling. That is investigating the community participation in the neighborhood development project. Now, number of clusters. The sample size calculation for cluster sampling, dividing number of clusters needed. Cluster sampling has always two-stage sampling. In a cluster sampling, first of all, we decide the area. In which area we are going to select the sample. This is the first criteria of the cluster. And suppose I select the cluster, in that cluster, I'm going to take a sample in a very random sample method wise. So here is suppose if you plan the select 10 clusters and my population size is 500. Now I have to calculate first the average cluster size. So the cluster size m is equal to n upon n, that 500 divided by 77. Now we have the 7. Now I have 7 clusters. And according to 7 cluster, I'm going to calculate the sample size in each cluster as a 77. Therefore, approximately 77 clusters will going to have a sample size over here in a cluster sampling. Here is the example, that is systematic sampling. This systematic sampling method normally used in the industrial areas. Wherever the quality control is there, we are taking the samples from the quality control methods. Then in the quality control, what we did, we will take a sample from every kth interval. That particular kth interval we have to decide, and exactly the sample size we are going to calculate according to that. Suppose my population size is a 10,000 and n is equal to 500. Then this 10,000 upon 500 will give me my 20k. Then every 20th person is my population size or a desired sample size. According to, we will calculate our sample size in a systematic sampling. This is a very easy way of the systematic sampling. Now we are going to discuss about the how to use our G power tools. Okay. So suppose first of all I need to understand you. This is a particular free website to download the G Power tool. That www psychology HHUD. This is a particular website. Other websites are there to download the G Power tool, but those are the paid websites. All are the paid. But this is a psychological website. This is psychology.hhu.de. It is a free website. You can take this particular link. With this link you can download the G Power tools on your computer or the laptop. Okay, the simple thing is that. Now we are going to discuss about the G Power tools. That first of all, 3 basic steps are here. First of all, I have to select my appropriate test. As I said previously, that how exactly I am going to do my statistical analysis, by which test, by which data, by which method. Then I will put my input parameters all over here and determine the effective size over here, the effect size, and I will calculate my sample size. Very simple. Whatever the research design you have, this is the G Power tool. It is the best method to calculate the sample size. This will give to you all the things. That statistical analysis this will give. This will give you the power of the test. This will give you the level of significance. This will give you the allocation of the results, that either it is a 1 sample, 2 sample, 3 sample. This will give either your data is a multivariate, univariate, bivariate. Associated data is there, correlated data is there, multivariate data is there, whatever type of data is there, whatever type of test is over there, but we can use this particular G Power tool for any of the study. So we'll go over here. So we discuss about the assignments afterward. I'm going to show you that how we are going to calculate sample sizes. Now, is it visible now to you?
Yes, ma'am.
Everybody tell me that is it visible for you?
Yes, ma'am.
Ah.
Can you zoom in? Is it possible to zoom in, ma'am?
Yes, I will see. No, it is not possible to zoom. No, it is not possible to zoom.
Okay, ma'am. Fine.
The window of the G Power is like this only. It is a small window. It is very small window. The window is like this. Okay. Now you can see over here. Whenever you use that particular link of hhu.de, you will find this G star power 3.1.9.4. This version is only free version. Other versions are paid version. And the payment is in dollars. So take a precaution, or if you are going to pay, then it's okay also. But G power 3.1.9.4, it is a free version. Okay. Now you can see over here. Here is the one in the above above this particular ribbon, there are the tests. Suppose you click on a test and there are the tests of correlation and regression. Now, whatever we have been seen already, those all tests are over here. Like a correlation of the bivariate model or the point estimation or the tetraconic model or the correlation to dependent variables means numerical correlation. Again, the qualitative variable Spearman's rank correlation, bivariate regression, linear bivariate regression, multiple regression, all the models are available over here. Whatever may be the statistical analysis, all is available in this particular test. Second one, if I go for the mean, then see here, suppose I have only one group or a single group, it is a survey study. Then in the survey study, what we do, we are taking the analysis for the related to the one group, that how exactly my data is scattered among the mean of the group. Therefore, it is a one group different from the constant. Again, one group for the normality is not proved, non-normal data, then we are using Wilcoxon or maybe match pair test. Wilcoxon match pair test. If the two independent groups are there, means two comparative groups are there and sample sizes are not equal at all. I don't need the sample sizes equal. Then also we can calculate the sample size. Again, many groups are there, then ANCOVA is there. Again, many groups are there, but I want only one dependent variable, then we are using the ANOVA test. In this way, you can find over here, all the test is available over here. All the analysis is available. Now we'll see the proportions. One group proportion or inequality McNamara test or Fisher exact test or the Z test. All the tests are available over here. You can see over here. Now, what we have to do first of all, whenever I have my research design, I decided my data collection methods, I decided my sampling method, then after the sampling methods, we set our hypothesis. According to the hypothesis, we are going through the parameters, that what is dependent variable, independent variables, lurking variables, confounding variables, that all has to be decided. In that particular variables, I decide what is how many of I have numerical variables and how many I have qualitative variables. That is a categorical variables. According to that, we'll go for the test of family. Now here is the icon test of family. You can see over here. My cursor is there, test family. Okay. Increasing the font size is not possible, ma'am, because this is the only table that I have. No. I'm trying to increase it, but it is not possible. That window is like this, ma'am. Only the window is like this. G Power Tool say window is like this. So at the left hand side, there is a test family. In that, if I click on test family, there 5 tests are there. Exact test, F test, T test, chi-square test, and Z test. These all tests will cover our all statistical analysis. So this is the test family. Suppose I select here the t-test family. One is that family I selected. Now see over here. Now the statistical test. Which statistical test we are going to use? Now we decided that I'm using the one group test. One sample case. That is the means different from the constant one sample case I'm going to use. Now, what type of power of analysis do you need? We need to select a priori. Priori means computing the sample size for the given alpha, power and the effect size. Okay, all the things are given here. So I select priori. Should I say again? In the particular G power tool, at the left hand side, there is a t-test, test family. How I decide my test family? According to our parameters. That how many parameters we have, how many variables we have, that will decide what exactly statistical analysis I am going to do. According to that, I'm going through the test family. Either it is an exact test or F test. F test is used for comparison of the variances. T test is used for, that is what is the spread about the mean or the standard deviation or the comparison test of the before and after. Okay. Again, the chi-square test is there whenever I have totally the qualitative data. Okay. In that case, we are using all the variables are categorical variable at the different levels. Then we are using the chi-square test. And the last one is a Z test. Whenever we are going for the population studies and having the different types of populations and comparative, maybe one group, two group, three group, four group, Solomon four groups, then we are going to use the Z test over here. So this is about the test family. So I decided that the one T test I'm taking here. Now the statistical test. Which statistical test in the T test I'm going to use? So we will take only the difference of the mean. That is a one sample case. One sample case. Okay. We'll take a simple example that I have a measurement scale. Then the length of the measurement scale, it is a 5 inches. Now, whatever the lot I have got, it varies between the 4.98 to the 5.11. This is the sample that what the lot I have. So I need to discuss about that either my mean is correct or not. Should I accept this lot or not? That's why I have taken that the spread about the mean, it is a difference of the constant, it is a one sample case. In, in such an example, we will consider this. Now, the type of power analysis here, suppose I click on this stage, then there are different things that we can calculate the mean mode median or post hoc test or the sensitivity, but I need only the sample size. So I click on sample size. It is a priori computation. Priori computation. So now you can see here the input parameters are tails, one tail or two tail. So normally we will take a two tails. Okay. Then the effect size D. Effect size, whenever I click on effect size, I will find the three levels. Effect size convention means either the small effect is there or the medium effect is there or the large effect is there. Okay. The effect size matters that which sampling method you are going to use. The sampling methods, different sampling methods gives you the different effect size that I discussed yesterday. It may be the design effect or maybe the effect size or it may be the sample design size. It lies between 1 to 2. Therefore, if my effect size it is a higher, then it is a 0.80. Suppose I select the higher effect size, then sample size is low or a lower. If I select the small effect size, then my sample size will rise, increase. That is why normally we take a 0.5 as a median effect size. Or now, alpha error of probability, it is a 0.05. 0.05 means 5%. Now, how it is 5%? 5% means 5 divided by 100. 5 divided by 100 will give us mathematically 0.05. Therefore, level of significance or type 1 error, alpha error, we selected as a 5%. Now, power of test, it is already given. It's a 0.95. But we can check this to the 0.80. Minimum power of test, we can take it as a particularly 0.80. So, 1 minute. Calculation table will go over here. Okay. See over here. Now what we did? We select the test family. We select the priori. The two-tailed test I am going to use. Effect size I selected as a moderate effect size or level of significance type 1 error as a 0.05. Power of test 1 minus beta, it is a 0.80. That means I am very confident about my results. Now with this, we'll go for the calculate. Now you can see over here. The total sample size I got here 34. This 34. This 34 has a critical t value. Already the t value it is given, it is a p value is already given. Before the statistical analysis, I got it here. Now I am very confident that my test is very useful. Why it is so? Because power of test, it is a 0.80. Then in the above, in the about diagram, you can see the diagram over here. You can see diagram over here.
Yes, ma'am.
In this diagram, you can say this is a red, it is my null hypothesis. The red diagram, the red curve, you can see the red curve. This red curve, it is a null hypothesis. Now you can see my data is a normal data. That's why my hypothesis shows me that it is a null hypothesis. Again, this is blue line shows us it is an alternative hypothesis. And what exactly the critical region of it? Critical region of it. You can see here alpha by 2, alpha by 2. This alpha by 2 is my rejection level of hypothesis. Now this rejection level of hypothesis, it is my 5% level. Now I can see this 5% over here as a alpha by 2. It is a 2.5% over here, and here at the left hand side 2.5%. 2.5% plus 2.5% will give us the 5% of the data. Therefore, this particular 2.5% at the right hand side alpha by 2 and left hand side alpha by 2, these two together will give us the alpha percent level of percent. Therefore, I can see the rejection region over here. This is my rejection there. If I reject my hypothesis, then this will hypothesis rejected from this alpha by 2 area and this alpha by 2 area. Now, this is my 0.80 power of test. This is the beta type 2 error. How much error do I get? That this beta error should I get. So in this way, you can see your things that how my hypothesis or what exactly the level that I am going to accept. This is the acceptance level I can see. Suppose we change our power of test to the 0.95. We'll see. 0.95. Okay. What I did, I changed my power of test. It is basically 0.80, but we will increase the power of test and I need the accurate results. So I will go for the 0.95. What will happen? Now, this power of test will give you the sample size. It is a 54. 54 sample size. The sample size has increased. Now, I'm trying to use the largest efficacy. So again, I'm going for calculation. Then the sample size reduces because I choose over here. You can see the alpha levels. Now the normal curve is very acute. This is the acute distribution. Normality but very peak distribution, and the alpha by 2 reduces. It is reduces. Again, here is the reduction. In this way, you can find the critical value also changes as a t is equal to 2.0738. Okay, this is very easy for the sample sizes. Now, in the same thing, how I'm going to put this particular results in my dissertation, or how I'm going to put this results in my thesis. So for that case, here is the one. It is a protocol of power analysis. You can see over here. This one, t-test for the means difference of constant. This all, whatever we have done over here, it is written over here as a t-test. And this is can be copy paste in a proper way. So you can put this copy paste results you put in your particular dissertation or a proposal. Okay, this is a simple way. So again, now this I showed you about the one sample case, but now I want to the graph of this. Either my distribution or whatever I data collected should be a normal or not. So I will plot this particular variables, draw the plot. So in the plotting, we will get that power of test. In this power of test, the effect size we will see whole the data is in a proper way. It is a curvilinear data, curvilinear. So whatever the sample size I am using depends upon the normality of the data. Suppose I am doing this with the normality, therefore whatever the results on the sample I should get, Those all samples are very reliable and valid and the precise results. I can easily use these results for the next predictions. So this is one of the thing. So we discuss here again another case over here. Take an example of the t-test, but I have a two groups. Now I have a two groups. Now I have a two groups, two dependent means. Chalo, match pair test. What do you mean by match pair test? Match pair test means we have taken the two groups of the same age group. Okay, suppose we have the two groups, male and female. The males are of the age group 30 to 50 and females of the age group 30 to 50. Now this is a matching. It's a matching criteria, matching inclusion criteria. The matching specifications are there. This is the match group. I want to see the difference between the male and female responses, but the age groups are the same, matching criteria is the same. So for the simple thing, we have taken the match pair test. Now again the type of power analysis, priority analysis, we select here the sample sizes. Okay. Difference between the two interpreters. Now, the tails we have selected two test, effect size DZ, power of test. Now we are going to calculate this. And 51. T-test. Depend of the two groups. Independent means two groups. Now you can see here. The input parameters tail size selected as a two tail test. Effect size it is a 0.5 moderate effect size. Again alpha level 0.05. Power of test 0.80. Location, allocation ratio. Allocation means if there are two groups, then each group has a equal sample size. Both the groups have equal sample size. It is allocation ratio. Suppose I change this allocation ratio, then the sample size also changes. I will show you how we will do it. So I will go for the calculations. So you can find the sample size in the first group it is a 64. In the second group again it is a 64. Now you can see here the alpha hypothesis, how we set the hypothesis over here. Critical value of T is 0.1.97 over here. Degrees of freedom and power of test it is again 0.80. Therefore our sample size calculation is right. Now suppose I change this power of test as a 95%. Sample size naturally it will increase. Okay. Suppose I take a effect size higher. Effect size higher. Then again sample size lows. Okay. It is only 42. So therefore in the first group 42 respondents are there. In the second group 42 respondents are there. But in the experimental studies, suppose I have a experiment studies only for one group and the second group it is a standard group. I don't need to calculate it. So I put the allocation ratio as a 2:1. Okay, then I will go for the calculations. Then you can see here sample group number 2 has a 63 respondents, but in a sample group number 1 only 31 respondents are there. Therefore you are focusing more on the sample group number 2. The more focusing on the sample group number 2. So in this way you can calculate this particular t-test. Take an example of the particular chi-square test. Now in the chi-square test we are finding the variance, difference of the variance. Now again we calculate what is the difference, two tail test, one for ratio is 1:1 again, and I will find the sample size with the difference. Here for the sample size it will come for the 159. Can you tell me, anybody can tell me that why the sample size is higher for the chi-square? or higher for the qualitative data? Can anybody tell me? Here we are using the chi-square test. That means all the variables we selected or all the responses we are selected are the categorical variables, means quality variables. Whenever the quality variables are there, the data has measured in the terms of scales. Those scales may be the Likert scale, semantic dependent, semantic balanced, or Thunderston scale. Many types of scales are available. I am collecting the data with a priority scales. Then the scales, it may happen that it have a memory effect or a bias effect, or maybe the any type of effect is there. A bias effect is there. Precision is low. The test is non-parametric. That is why I need to take a sample more than 120. A simple survey study is there, then I should take a sample size more than 120. The more than 120 sample will prove your results appropriately. Therefore, whenever I go for the qualitative type of data, we should go for the sample sizes more than 120. A survey studies or the qualitative studies, then go for the particularly sample size more than 120. This is the one thing. Again, should I go for the XY table, draw the plot, we'll see the same plot over here. Data is normal, but we are taking the independently chi-square test. Just go for the F test, that how we are calculating about the variances. Now, you can see here, different types of ANOVA tables are here, but we go for the between the factors ANOVA. Then again, I will find out my effect size, alpha 0.95, number of groups, number of measurements are there. What levels, exactly the levels of parameter, 1, 2, 3, 4, what levels of parameter do you have? And among that parameters or the levels of parameters, we calculate the ANOVA. Therefore, the calculation is different among the ANOVA. You can see the graph over here. Above the graph, you can see the variances. See, the alternative hypothesis will go like this and the null hypothesis will go like this. Data is not having the different levels. Therefore, this is the best way to calculate with the G power tools. Is any queries there? Yes. Z test. Again, we'll see the correlation methods. That is a Pearson's correlation. See here. For the Pearson's correlation, how I am going to calculate the sample sizes. Sample size is higher, then it is a 595. Okay. Suppose we'll take a simple correlation. Then calculation is according to the critical values. But we are not using this. Normally we are taking the t-test and the z-test. T-test, chi-square test and the z-test. Yes.
Excuse me, ma'am.
Yes.
Ma'am, my title is Influence of Leadership Style, Motivation, Work Culture, and Employee Performance.
Yes.
So, in this title,
Let me see. Again tell me.
my topic is Influence of Leadership Style, Motivation, and Work Culture, and Employee Performance. I'm not able to identify which test will be applicable for the study.
This applicable is ANOVA only. ANOVA.
Okay.
ANOVA. And you need to do the factor analysis.
Okay.
Whatever the parameters you have choose or whatever the questionnaires you have been choose to prove your study. First of all, with the questionnaire, you do your content analysis, content validity index.
Okay.
First of
Okay.
all, do the content validity index.
Validity index.
Content validity index.
Okay.
CVR. That CVR will tell you that how exactly your questions are right or wrong.
Okay.
Okay. After that, do the factor analysis.
Ma'am,
Factor analysis,
how to identify the content analysis validity index, ma'am? Can we
that is
get
a
the...
big procedure, but
Okay.
you will find with the statistician that how I do with the content analysis. Okay.
Okay, ma'am.
But the
Okay.
content analysis will say you that exactly whatever
Mhm.
you choose your constraints. These are your
Okay.
constraints. Motivation is constant. Work
Okay.
culture is a constant. Is it there?
Okay. Yeah.
These are your constraints.
Okay.
According to these constraints, you are going to study.
Okay.
So these constraints have some questionnaires in that.
Okay.
Okay.
Yeah.
What exactly the questions are right or wrong, that should be just first. This is the
Okay.
first way analysis. After that, you have to do the factor analysis to reduce either these questions are reduced or have to be kept as it is.
Okay.
Then we will go for the test of particularly Z test and afterwards ANOVA test.
Okay.
Okay, here is we go for the multivariate analysis. As
Okay.
well as you can prove with this the discriminant analysis. Discriminant analysis means the numerical variable is there, that is your performance,
Okay.
and it depends upon the categorical variables. Three
Okay.
categorical variables are there. Therefore, here we go with the discriminant analysis. And with
Okay.
discriminant analysis, you can prove your results.
Okay. Ma'am, one more doubt.
Yeah.
Recently, I met one statistician. He
Hmm.
told that it is not possible to develop the questionnaire for this topic because there are several measurement scales are available.
Hmm.
Can we adopt, because the scales which is available is not, the
Hmm.
questions which is mentioned in the scales is not matching with my study? Can
Hmm.
I develop the questionnaire on my study?
You can develop your own questionnaire. It
Okay.
is called as a skill development method.
Okay.
Suppose you develop your own skill
Okay.
and prove it with a content validity index,
Okay.
then that can be published as your patent.
Okay. Okay, ma'am.
Yeah.
Because based on...
It may be your copyright for it, that you are developing scale, you are proving that particular scale with a content validity index in a proper ways. It is a procedure in a AMOS SPSS that you can prove your results. And
Mhm.
suppose you do that in your own way, then you may get a copyright of it or maybe the patent of it.
There is no
But
restriction
your
to
own
develop,
skill
no, ma'am.
is better one, na?
There is no restriction for developing, no, ma'am.
No, there is no restriction at all.
Okay.
Because every area is different.
Okay.
Whatever the environmental places or climatic places or the perceptions over there in other countries, those may are not available in our country. Therefore, we can develop our own skill.
Yeah, based on the parameters and based on the
Scales
literature.
are there. Scales are there in the market
Yeah.
to sell. But without taking that scale, you can develop your own skill.
Okay.
It is a better one.
Yeah. Ma'am, I have prepared the questionnaire based on the parameters and based on the literature review.
Yes. That is the way we are making the parameters.
Okay. Thank you very much, ma'am.
Yeah. So this is about the G power analysis of the sample size calculation. So we'll go by now the one by one assignment that we are going to prepare the assignment. We'll discuss the assignments. One thing. So here is the assignment number 1. I think that everybody should participate in this to study the assignment, sound and calculation method. Suppose you are planning to study to compare the effectiveness of two different training programs on the employee productivity. Then which sample size calculation method you want to use and why? This is my question. Comparison of effectiveness of two different training programs on the employee productivity. Which sample size calculation method you are going to use? Yes, anybody?
Stratified.
Not necessarily stratified, because two different training programs may be given to the Employees only. The same employees can achieve the two different training programs. It may happen, or there may be two different groups, that for the two different groups we are giving the two different training programs. But if for two different groups we are giving two different training programs, then we cannot find the similar results in it. We cannot compare it. Therefore, for the same employees, we are applying two different training programs.
Madam, stratified random sampling.
Stratified, again I say, the stratified random sampling is not necessary over here. Here we only need a sample size calculation of two proportions.
Simple t-test.
Simple t-test is also will go. Simple t-test, before after. Before after, for the one program, there is a test before and after. Calculate the sample size. Okay. Then for again the same people, the same sample size will having the second training program. Again before and after. This is a particular
Also with the ANOVA.
crossover study. Crossover study is there. Therefore, according to the population, suppose a particular industry has, how many people are there? 500 people are there. Then out of 500, taking a population, keeping the margin of error as a maybe 10%, alpha level of significance as a 5%, in a simple way, z is equal to n square pq upon d square. This is a simple formula. You can find out the exactly the n and take that particular n number of employees and apply the two different training programs. Clear? Yes or no?
Yes, ma'am.
Yes.
Yes, ma'am.
Now, you can see here, this is a question number 2. You are designing a research study to investigate the impact of new medication on a blood pressure level in a hypertensive patients. Impact of new medication on the blood pressure levels in a hypertensive patients.
This will be t-test, ma'am, before and after?
Yes, simple pair t-test, before after pair t-test. Already the hypertension patients are with us. Okay. We check the hypertension before the treatment, give the medicine, and check the blood pressure after the medication. This is a before and after simple t-test. Okay. Sample size calculation is very simple, either by the G power tool or maybe the EPI info or maybe the proper simple formula, and is equal to NPQ divided by D square. Simple. Okay. This is pair t-test. Now this one, question number 3. You are conducting a qualitative study to explore experiences of individuals who have recently immigrated to a new country. Qualitative study to explore the experiences of individuals who have recently
chi-square test. Chi-square test.
Listen. Read again the research question. Read again the research question. You are conducting a qualitative study to explore of the individuals who have recently immigrated to a new country.
Ma'am, calculating sample size for this will be difficult because of the number of people involved. The population is very large.
Yes. That is what I expected. There is no need to calculate the sample size over here because the study is not possible. The who have recently immigrated to a new country. How many countries are there? And how the people are immigrated over there? How you are going to collect your samples? With the global also, by the emails also, or by any of the methods also, it is not possible at all. Okay. Therefore, the study will not be valid and feasible. Therefore, there is no question to calculate the sample size over here. Yes, I agree with you, ma'am.
Thank you, ma'am.
Question number 4. You are conducting an observational study to examine the behavior of the shoppers in the retail store. How would you determine the sample size for this study? observational study to examine behavior of the shoppers.
Systematic random sampling.
Systematic random sample, yes, it will do. Yes, will do. But again, see, the observational study is there. What is the challenges of it? Systematic sample will do that every 10 customer, or take a particular shop. In that particular shop who are there, examine the behavior of that. But you are not dealing with them with a questionnaire. You are not dealing with them with an interview. You are not dealing with them of any of the method that will have the response of the people. You need to only the observe the people. Is there any method? Systematic is also do simple random method. Simple random. Okay, it may be the convenience sampling of you, but it may having the convenience sampling of you. The sample size will determine over there. Okay, you just decide with your convenience that how much sample I need. Okay, this will go with a convenience method sampling or systematic sampling method. Question number 5. You are conducting a survey to determine the satisfaction level of students with the campus facilities. Conducting a survey to determine satisfaction level of students with the campus facilities.
Ma'am, simple random sampling?
No, here you have to use the stratification. Here you have to use the either cluster or the stratification, because total student population is a 10,000. Okay, it may be divided into the different faculties or the different departments. Okay, with the campus facilities, we are conducting survey of 10,000 people. 10,000 people in the campus facility. Therefore, here stratification will do. Okay, stratification will conduct the study. Question number 6. Your research aims to explore the performance of the student from different schools, districts in the standardized test.
Cluster.
Cluster, yes. Cluster is there. Different school districts in a different standardized test. Therefore, the districts in your region, it said it is a region. That means it is area. Whenever we divide the area, it is a cluster sampling. Question number 7. You are planning to conduct a depth interview with the employees from the various companies to understand the experiences with the online remote work. How would you determine the sample size for qualitative study? Yes. In-depth interviews with the employees from the various companies.
It is a case study, I think.
It is a case study, but you can apply the particular study. It is a simple cross-sectional study. It is simple study, but it is a cross-sectional study. Therefore, you need to first of all identify which are the companies you are going to take. Then understand how take a list of employees over there. Then you have to decide your sample size, that this one is my sample size, this is my questionnaire, and this is my qualitative study. I'm going to consider the taking the in-depth interviews with only those people. Okay, take a inclusion exclusion criteria or maybe specifications that the employee should be at the level 1 or level 2 or level 3, like that. Put a proper specifications on that, then you can do this study particularly ready. But the total sample size decided by only chi-square test. Sample size determination will go with the chi-square test. Question number 8. Does a new educational intervention improves the students' academic performance compared to the traditional teaching methods.
Yes, ma'am. Definitely.
Does new then how should I select the pre and post test course? Is it that new educational intervention improves academic performance? Therefore,
Pre-test.
pre-test, post-test course are there with the new method as well as by the traditional method. Therefore, two groups are there. Comparative two groups are there. Use the simple formula that is equal to P1 minus P2, like that. Z alpha minus Z beta. That formula you can use over here. Calculate our sample sizes. Question number 9. Experimental study. The pharmaceutical company aims to detect a 10% reduction in the blood pressure with a power of 80% and level of significance 0.05. The standard deviation is already given here. Okay. Therefore, we can calculate the sample size with the simple G power tools. Okay. It is already given. The effect size is already given to detect the 10% reduction. 10% reduction is our effect size. Okay, power is given 80%, level of significance 0.05. Go with the standard deviation. You can use the simple formula also here that n is equal to n z square sigma square upon e square. That formula also will go with this particular example. Or the using of G power tool, we calculate the sample sizes. So this is from my side. These are my book publications I already told about you. And this is my contact. If anybody needs it, it is there with.
Ma'am, can I ask a question, please?
Yeah.
Yeah, ma'am. Suppose if we are comparing two groups, say one group is from rural, one group is from urban. So in that case, we might have to use stratified sampling.
Yes.
But since the groups itself are so big, so
Hmm.
how can we go about stratification, ma'am? Because the population itself is unknown. It's a huge population.
It is a huge population, but your research question is defined now over there. The research question is defined or not? Yes,
Yes, yes,
your parameters are defined.
yes,
Your
ma'am.
parameters are defined. Then in case take a pilot study. Pilot study in a urban, pilot study in a rural, take particular mean and standard deviation and go for the calculation of sample size with a two case in a EPI info. It will help you to calculate the sample sizes. It may be the population may be large in urban and rural, but pilot study will definitely help you in this case.
Yes, ma'am. Pilot study has been conducted,
Hmm.
but of course, pilot study has a very limited number when we conduct it. But when we are going for actual analysis,
Hmm.
it is very vast, ma'am. So can we use the
That
same
is why
method as
no,
we?
no, no. What I say with a pilot study, first of all, decide the sample size.
Mm-hmm.
Pilot study, two areas are there. Urban area, take a pilot study, take a mean and standard deviation. For the rural area, take a mean and standard deviation. Go for
Okay.
the sample size calculation with these two means and two standard deviation. That is a difference of mean, difference of the variances. It will give you the proper sample size in urban area as well as in a rural area. Okay.
Okay, ma'am. Got
Then
it.
you have to go for the analysis part.
Uh-huh. Okay, ma'am.
Huh.
Got
I
it.
showed
Thank you,
you
ma'am.
yesterday in a EPI info. Is it there?
Uh-huh.
Yesterday in a EPI info, I showed you
Uh-huh.
that EPI info will give you the mean difference sample
Right,
size.
ma'am.
Mean difference sample size. Go in that way, you will find the sample size, a proper sample size over there.
Thank you, ma'am. Thank you.
Yeah.
Ma'am, excuse me, ma'am.
Yes. Yes, ma'am.
I have already told my title, that is Impact of AI and Robotics to Gain Competitive Advantage in Allopathic Hospitals.
Hmm.
My respondents will be doctors, managers from the allopathic hospitals. It may
Yeah.
be the hospital which are using AI and robotics. Ma'am, which is the better statistical tools we can use for this study, ma'am?
Now, are you preparing the questionnaire or are you going to interview the doctors?
Questionnaire, ma'am. Through questionnaire, I'm going to collect the data.
Then show me first of all once the questionnaire.
Okay,
Looking
ma'am.
at the questionnaire, the parameters, I will tell you at what exactly statistical analysis you need.
Okay, ma'am. I'll mail
It
to
may
you.
have the many parameters.
Yeah, ma'am.
It may have many parameters like infrastructure or maybe the other qualitative parameters or the responses or
Operational
the business
efficiency.
decisions or the PD, IPD
Yes, ma'am.
facilities and all those things. Therefore, better that show me that I will tell you that what statistical analysis do you need.
Okay, ma'am. Thank you so much.
Okay, sure. Yes, sir. Hello. Is there any question? Bholanat sir?
Yes, ma'am.
Yes. So I think the questions has been completed.
Okay.
Hmm.
So, thank you so much once again. And thank you, ma'am, for the wonderful sessions and your presence yesterday and today. The
Yes.
sessions had been wonderful, and I'm sure that there will be a lot of takeaways from the participants. And as you said, that if anyone needs any help, they can directly connect with ma'am. Okay, she'll be
Yes.
able to help all of
Anytime.
you.
Anytime.
I think that would be great. Okay, be in
Yeah.
touch with ma'am. And anyone needs her contact details later on, you can post me message in WhatsApp. I'll forward the same. That's one part.
Yes,
The
sir.
yeah.
Need her contact number.
Yes, I'll post it in the WhatsApp group. Okay, once again, ma'am has shared. Again, I'll share it. You can directly be in touch with her. And the certificate, e-certificate will be emailed latest by Thursday. Okay, so we'll do it surely. Thank you so much once again for all of your participation, especially in the weekend. We understand that all will be busy at homework, but still, okay, we had to plan in the weekend because so that no, we can have more flexibility. Thank you once again, and thank you, Dr. Anjali ma'am, for
Thank you,
your
sir.
support.
Thank you.
It has been a
Thank you for
wonderful
giving me
session.
this opportunity.
No, no,
And
no.
I hope that the sessions will be continued for the research
Yes,
development.
yes. We'll continue some more programs, and I request you kindly share the topic so that we can plan it out. And I'm sure it would be useful for all the participants. Thank
Yes.
you once again, all of you, and wish you all a great weekend. Thank you so much. Thank you.
Thank you. Thank
Bye
you.
bye.
Bye.
Thank you, ma'am. And thank
Thank
you,
you, ma'am.
sir.
Thank you, ma'am.
Thank you.
Thank you, ma'am. Thank you, sir. It was a great session. Thank you.
Thank you. Bye
Thank
bye.
you, ma'am.